Okay, this is a recording of the last part of notes for 7.5, and it's the application section, so I'll be going over problems 8 and 9. And so if I can't imagine that I'll have gotten past this on Wednesday, but if I have, you can fast forward into this. And if I haven't gotten this far, I will make another recording clip of that. So these are applications, and we've looked at that equilibrium point concept for a system of demand and supply equations. And the next example goes through two related concepts that economists call consumer surplus and producer surplus. So here's a nice little picture about that. And you can see the consumer surplus is kind of that little blue, the producer surplus is the pink there, and the equilibrium point is kind of that special point where we kind of everything balances out. And so the consumer surplus is the amount consumers are willing to pay above what they actually paid. And I'll slide that down. The producer surplus is the amount producers would have been willing to receive below what they actually received. And that's in that little pink area. And so as we look at these problems, we want to keep that model in mind. If you want to pause it and jot down that little picture, you can do that. Otherwise, I'll be moving on. And so then I've talked about all that. Here's just a bigger picture of that same thing. And then here's problem number 8. And the demand and supply equations for a new type of video game console are P equals 180 minus 0.00001x and P equals 90 plus 0.00002x, where P is the price per unit in dollars and X is the number of units. And our job is to find the consumer surplus and producer surplus for these two equations. And so we're going to use this system of equations. We're going to find the point of equilibrium, and then we're going to graph this system as we go. So let me move to the next slide, and we'll get started on this. Oops. There we go. Oh. I went a little too far there. Okay, so we want to, step 1, find the equilibrium point. So find equilibrium point. Hopefully I spelled that okay. And so we're going to set those two things, the demand equation, which is this top one, and the supply equation, which is the bottom one. And we're going to set those equal to each other. So we want to know when P is equal. P is the price per unit to each other. So we can say 90 plus 0.12340 is equal to 180 minus 0.00001x. And then we'll add the 0.00001x to both sides, subtract 90 from both sides, so we'll get 0.00003x equals 90, and then x equals, when we divide 90 divided by 0.00003, we get 3 million. 3, 1, 2, 3, 4, 5, 6. And so that's what x is equal to. And just a reminder that x is the number of units that we're going to be getting. So x equals the number of units. And just a reminder, P was the price per unit. Just thought I'll add that a little bit just to remind us. So now we want to find P. We can put it in either one of those. I'll just put it in the bottom one. So P equals 90 plus 0.10002x, or not x, times 3 million. So let me multiply that times 3 million. And when we get that, we get P equals 150. So our equilibrium point is at 3 million, comma, 150. So 3 million units, price per unit's $150. So then our second job is to kind of figure out the consumer surplus. And the consumer surplus, and I'll write that right here, the consumer surplus. And that's going to happen when the demand, when the price per unit is less than or equal to the 180 minus 0.00001x. And so we want that to be P is less than or equal to 180 minus 0.00001x. And so P is less than or equal to the demand. And then we also want P to be greater than or equal to 150. P is greater than or equal to 150. So P is greater than or equal to the equilibrium. That's a U. And we also want x to be greater than or equal to 0, just because we obviously want to make more of those as we go. And then so that's one part of this graph that we're going to make. And then the second part is going to be the producer surplus. And it's hard for me to quite see everything. Maybe I will try to squeeze it in right here. The producer surplus is going to be when our supply equation, we have P is greater than or equal to 90 plus 0.00002x. So P is greater than or equal to the supply. So P is greater than or equal to 90 plus 0.00002x. And that's P is greater than or equal to the supply. And then P is less than or equal to 150. So P is less than or equal to the equilibrium. And of course, x is still greater than or equal to 0 as we go through that. And so now we need to kind of graph these as we go. And I'm gonna go down here and set up my axes and everything. And hopefully you wrote all this down. So let me just kind of put that there. If you haven't written this down, pause this recording, write that down so that you can have it, and then you can follow along as I'm graphing that. So here's the graphing part. So x is the number of units, and so we'll make our x-axis go by millions. So this is 1 million, 2 million, 3 million, 4 million. So 1, 2, 3, 2 million, 3 million, and 4 million. Hopefully I have all the zeros in there. And then over on this other side, we'll put like this little squiggly line, if you remember in graphing, that means that we're going to adjust that height and we're going to skip some things there. And then we'll maybe start this at 75. And I'm just going to go 2 boxes to 100, 2 boxes to 125, 2 boxes to 150. And that's, if you remember, important for our equilibrium point. 2 boxes for 175, and then 2 boxes for 200. So just a reminder, on our x-axis, we have the number of units that we're producing, and then on the y-axis, we get P, which is the price per unit. Okay, so then as we graph those, we want to graph the demand. Oh, let me, oops. We're going to graph this, we'll graph the supply surplus. And so when we graph that, we're going to have, or excuse me, we'll, well, we will start with the consumer surplus. So P is less than or equal to 180 minus 0.00001x, and so I'm gonna say probably I will take my calculator and find some values that just kind of work in there nicely. And so the easiest way to do that is if I take, maybe I'll use my space right over here. I'm going to graph P equals 180 minus 0.00001x, and I'll just put in some values to kind of graph that. And I know the y-intercept is at 180 and the slope is negative 0.00001x, or 1. And I'm just going to say, well, if x is 0, p is 180. That would give me a nice point. I already know that if x is 3 million, then p is 150. So that'll give me kind of those 2 points. And I can kind of graph that as I go. So let me just find those. I've got, boy, I apologize, but I feel like I need to move my axis out a little bit there. And so I'm going to go 2 boxes as we go for my different millions. So there's 1 million, 2 million, 3 million, 4 million. And that just is going to make it a little easier for me to graph. I'll try to tell you that before you watch this recording. So even though I do it the other way, you can do it like that. So I have my 0, 180, and there's about 25 in there. So that's a little above 180, and so maybe it'll be kind of someplace along there. And my 3 million 150 is kind of right there, and that will be one of my lines. And there we go. So I've got that line, and I know that I want to shade below that, but let me get all my lines in here so that I can kind of look at what's happening. Another line I need is that equilibrium one, and so let me just draw that in right away, and that's when, oops, when P equals 150, and then I'm going to get my last line in here, and For that one, I have that P equals 90 plus 0.00002x. And if I put in 0, I get 90 for a point. I also know that goes through the 3 million 150. So that's an easy point to find. I have 75, so 90 maybe would be about there. I'm going to go through that other point. And for this one, I just kind of have to draw these lines in. That makes it a little easier for me as I go. And then I'll kind of go back up here a minute, and if I look at this little group, and maybe I'll just kind of see if I can grab those. Yeah, and I'll group them and clone them. And then I'll kind of bring it down there so I can see it. And I'll do the same thing with, oops, this one. These three. Missed one of them. Okay. So that I can kind of see those as I'm looking down here. So now I've got this one set of equations right here, and I know that P is going to be less than the 180 minus 0.01, and I'll do some shading. You might hold off on shading until I kind of get it, because I'm just going to shade the region here. But P is less than, that would be shaded down here. P is greater than 150, that's shaded above this line. Like this, and greater than 0. So what we get is that little triangular wedge shaded. And that's what we expected based on the model that you maybe traced as you went through that. And to be consistent with that picture we had, I'll shade that in blue. And that will be that top portion right there. We'll shade that in blue. And that's our consumer surplus. And then the other one, so I can get rid of these three right now because I have them up there. I just couldn't see them. And now I want to look at these other ones for a minute. And so now I know, and again, I'm going to shade, but then I'm going to erase that afterwards. So I'll just use this green again. If P is greater than or equal to 90 plus 0.00002x, that means it's going to be above this line. P is less than 150, that means it's going to be below that line. And greater than 0 means it's going to be, this way. So we're going to get that little bottom wedge, which is what we would have expected anyway. So we'll shade that in maybe this like purple color, and that's kind of that pink, and that is our producer surplus as we look at that. And so this is what we end up with as our picture here for this problem. And then the next thing that we want to do, it said we want to define the consumer surplus and producer surplus for these two equations, and we're kind of done with that part of it. And then the next thing that we want to do within this problem is we want to find the area of the shaded triangles to show that's the surpluses. So I am going to first let me get rid of this stuff. Oops. Let me get rid of that because we have that above, and I just drew those accidentally. And then from my work before, I will keep this work, but I'm going to just slide it up a little bit so that I have better use of my space. And that helped me graph that. Now, my next job, and I'll call this step 4, is to find the area of the shaded triangles to show the surpluses. And so the consumer surplus, I'll maybe do that in blue. The consumer surplus, for that one, we have this little blue triangle here, and we can just do that old area is 1/2 base times height. And so when you look at this, and I'll write in yellow and then I'll erase it, we can call the base from here to here, which is that distance right there of 3 million. And then the height is from 150. If you remember, that point of intersection was 180. So that height is 30. So, and this is a right triangle, so the base is 3 million, the height is 30, and I'm going to get rid of all that yellow that I just wanted to think things through. And so then the area of the consumer surplus triangular wedge there is 1/2 times 3 million times the height, which is 30. And so that area is 4, 5, 1, 2, 3, 4, 5, 6. So 45 million. That's the consumer surplus. And then we'll do the, we'll do the producer surplus. And I'll try to fit that in here. Producer surplus. And for that one, same idea, area is 1/2 base times height. I'll do yellow again, 3 million. And here from 50 down to that was not, or 150, 90 to 150, and so that is 60. This is a right triangle again, and so we can get that area as well. And I'll go back to this little purple that I had. And so area is equal to 1/2 times our 3 million again, times 60 this time. And so the area for that one is 90 million. Just to kind of look at that. And so we can compare those areas for the producer and consumer surpluses. And then I'll go through the slides a little bit from the book authors, and let me just kind of page through that so that we can see. That's just my work there. And this kind of just runs through that same thing. There's our consumer surplus and our producer surplus. Here's the book author's picture of that as we go. And then we can kind of see that relationship. Then the consumer surplus is the 45 million, and given in dollars, it's the area, but it is in dollars, and I did not write a dollar sign, so that's why I keep these slides so I can kind of make sure I say things correctly. So that is problem number 8, and now we'll move on to problem number 9. And let me just make sure things are still going for me. Yep. And so here is number 9. Now, I'm just going to tell you, take good notes on number 9 because we'll look at this problem again in 7.6. So in 7.5, we just look at it as a systems of inequalities and we graph it. And then in section 7.6, we'll talk about it as a linear programming problem. So I will tell you that you maybe want to write some good notes on this, and it will be on the YOLA site as well. So the liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, and 90 units of vitamin C. A cup of dietary drink X provides 60 calories, 12 units of vitamin A, 10 units of vitamin C, and a cup of dietary drink Y provides 60 calories, 6 units of vitamin A, 30 units of vitamin C. And our job is to set up a system of linear inequalities and describe how many cups of each drink should be consumed each day to meet or exceed the daily requirements for calories and vitamins. And what I'm going to do is I'm going to color code this a little bit just so that it's easy to follow. And I'm going to try to use my space well. So X is going to equal the number of cups of drink X, capital X. And then Y can equal the number of cups of drink, capital Y. So, and we need to meet or exceed the daily requirements. So we need to meet or exceed the daily requirements. Okay, so as you kind of revisit, kind of just look through there, notice that to meet those requirements in that top little sentence, it says we need at least 300 calories. So one of our constraints is about calories. We need 36 units of vitamin A. So one of our things that we have to meet is our vitamin A requirements, and then 90 units of vitamin C. So as we write our constraints or our that we're going to need, that's where we're going to get kind of some equations as we go through. And then just a reminder that X has to be greater than or equal to 0, Y has to be greater than or equal to 0. Those are kind of hidden constraints because, you know, we're not going to have negative number of cups of either of these drinks as we go. So I need to see this. I'm going to talk about calories for one of them, vitamin A, and vitamin C. And then I'll just call extra things to consider is X is greater than or equal to 0 and Y is greater than or equal to 0. So I'll kind of leave those. I'm going to have these three equations and unknowns. If I were here, I would maybe, you know, have you try to come up with that on a little separate piece of paper. But since that's not going to happen, we'll just kind of go through. And I will highlight as I go. So we need at least, and these are all at least 300 calories of nutrition. And so drink X provides, we get 60 calories here, and drink Y, X provides 60 calories, and drink Y provides 60 calories also. So they have the same number of calories. So our requirement here is however many cups of drink X we get, for each cup we're going to use 60 calories. However many cups of drink Y, which is little y, we're going to get 60 calories from that, and it has to be at least 300 calories total. So let me get rid of kind of all that scribbling I just did and say, to me, that means that 60x plus 60y is greater than or equal to 300. And for our, you know, exam part, we will have to kind of be able to do that as well. Then our next constraint that we're going to look at is the vitamin A. And so when I look at vitamin A, I need at least 36 units of vitamin A, so that's vitamin A. And then in drink X, I get 12 units of vitamin A. In drink Y, I get 6 units of vitamin A. So that means that, if I want my total vitamin A for every cup, which I'm going to have X cups of, or X, yes, cups of, I'm going to get 12 units of vitamin A, and for every cup of the drink Y, I'm going to get 6 units of vitamin A, and altogether I need at least 36 units. So again, let me get rid of some of that circling and underlining. And so to me, the vitamin A constraint is going to be 12x plus 6y, has to be greater than or equal to 36. And then our last one is going to be vitamin C, and I'll spend less time on that. So for vitamin C, I need the 90 units, at least 90 units. Drink X gives me 10 units of vitamin C. Drink Y gives me 30 units of vitamin C. And so you probably know this is going to be 10X plus 30Y is greater than or equal to 90. And then my job is to kind of graph these on this axis and graph. So I was really proud of myself because I put this little clip art in here, but I'm actually going to slide it out of the way a little bit so that it is not there. And I am going to see, no, that is not all attached. So let me, oh, wait, let me make sure I didn't. Okay, sorry. Let me get this and these axes kind of all to move up a little bit. Perfect. So I can use my space. These take a lot of space on the board. So, okay. So the cups of these drink mixes, I'm kind of expecting I can kind of go by ones, and I'm just going to go out from 1 to 10 and maybe 1 to 10 again. I'll use 2 boxes for every number. And let me just kind of think about that. If I had 10 of each, yeah, I'm going to have plenty of anything that I need. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on this axis, I'll do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. And zeros down there. Oh, 8 is as high as I got, so hopefully that will work for me. And then I'm just going to graph each of these constraints. So I'll color code them. We know X is greater than or equal to 0. Y is greater than or equal to 0. So essentially that's shading, for those 2 constraints right there. And I'll just kind of circle them. If X has to be greater than or equal to 0, that's all out here. And if Y has to be greater than or equal to 0, that's all up there. And so that's how we're in that first quadrant for our work. And we'll just kind of go with that. And then I'm just going to kind of do some work. 60x plus 60y is greater than or equal to 300. So I'm going to set that equal. I'm going to notice that I can divide everything by 60 there, and I can get just x plus y is equal to 5. So, and then I'm just going to say, you know what? That means if x is 0, y is 5. If x is 5, y is 0. So an easy way to just kind of pick a couple points to plot. And so I've got 5, 0. I've got 0, 5. I'll draw in my line. It's a solid line because it was greater than or equal to. Oops. And I'll make it green. And here's that. And I'll check my point 0, 0 as I look at that. And when I check my point 0, 0, I'll go back into this greater than or equal to. And so if I check 0, 0, I get 0 is greater than or equal to 300, and that is not true. So that means I'm shading outside of that. And when I do shade, I'm just going to shade kind of this area right here. And again, I probably won't leave all this shading on here, but I'm going out that way because remember, I want to at least meet my nutritional values. So if I go above that, it's not really an issue as far as that's concerned. Then I'm going to take my next constraint, which is my 12x plus 6y is greater than or equal to 36, but I'm going to set it equal to 36. Again, I'm going to do this. I can divide everything by 6, so 2x plus y is 6. If I want to get that in slope-intercept form instead of checking points, I can get y is negative 2x plus 6. So our intercept is 6. Our slope is negative 2, so down 2 over 1, down 1, 2 over 1, down 2 over 1. And that makes sense that if x is 3, that would be 0 there as well. Just checking kind of as I go, make sure I'm plotting things well. And then for this one, oops, let me find that purple color. For this one, my line is going to be there. And again, I'll check the constraint. I like to check 0, 0. I have in my mind what I think is going to happen there. And so when I check 0, 0, I'm really checking it in that constraint just to kind of remind you of that. So that's going to be 0 is greater than or equal to 36, which is not true. And when I checked 0, 0, and so it's again going to be kind of shaded out and away there as I go. So now, this purple one is right here. I kind of just added that little extra place right there. And so let me just get some more. I probably can't leave all this crayon stuff on here, but that's okay. And then I don't have room below here, but I'll go just above. So I have 10x plus 30y equals 90. I'll divide everything by 10. X plus 3y is 90. Yeah, I'll solve this one as well. So 3y is equal to negative x plus 90. Y equals negative 1/3 x plus 90 divided by 3 is, oh, I'm sorry. Look at that. I made a mistake there. And probably Danae is saying, Mrs. Jones, shouldn't that have been 90? Or 90 should have been 9? Because she's awesome at correcting me. And so I will say, okay, so 10x plus 30x, or excuse me, 10x plus 30y equals 90. Divide by 10, x plus 3y equals 9. 3y equals negative x plus 9. Y equals negative 1/3 x plus 3. And so I have an intercept of 3. And I have a slope of negative 1/3, so down 1 over 3 to right there, down 1 and over 3 again, should be maybe right there. I might even go down 1 and over 3. I think my second point is bad. Oops. So down 1 over 1, 2, 3, and I am, oh, that's because my first point was bad. Okay, let me back that up and get rid of all these points. So when I went down 1, 1, 2, 3, I should have gone to there. Down 1 over 1, 2, 3. Something still is not working well for me. That one is right. Down 1 over 1, 2, 3. The point should be right there. And so then down 1 and over 3. Gosh, I know mathematically where the points are. I can't find them on the graph. I'm a little frustrated by myself, but I think I have them now. And so then this constraint will go along here. Now our expectation, my expectation is that I'm going to be shading above, but I will check that just to make sure. If I check 0, 0 in this equation, then I'm going to get 0 is greater than or equal to 90, which is not true. And so that means it is not shaded. So I am going to shade above for this one. And so there's that line. And I'm staying above oops, above the y-axis and above the x-axis. So for this one, notice that my region is kind of an undefined region. It's going up and out to the top and right of that. And now I want to find, it says, how many cups, um, set up a linear system of inequalities to describe how many cups of each drink should be consumed each day to meet or exceed the minimum daily requirements for calories and vitamins. And so we're going to pick those edge boundaries for this whole region. And I think I have to find where all this shading overlaps. And let me kind of just, maybe I'll shade this in black. And what it's going to be, I think here, this is everything there. I think everything is above there. And so my final region that's shaded should be all of this. And of course out to infinity as we go. And so then I can find kind of those points that are going to be the key points. So it looks like one is right there, one is right here, one is right there, and actually the last one is right over there as we go. So the points that are at that boundary of our shaded region are 0, 6. This next one is 1, 4, it looks like. 1, 4. The next one is 3 and 2, 3, 2. And the last one, excuse me, is 9, 0. So like 9 cups of the drink X, none of the drink Y as we go. So that is this problem, and we will revisit that in the next lesson as well. And let me just kind of show you. This is probably what I will put on the Yola site, because I probably can't put all that crayon stuff, but it'll be on the recording of this lesson, and eventually I'll post that on the Yola site as well. And so that is the end of notes for 7.5.